box of mass 27 kilograms rests on a horizontal surface with coefficient of friction 0.3. A force P acts on the box as shown. If the box is on the point of slipping, find the value of P. So here's our box, 27 kilograms, horizontal force to the left P, and the thing is on the point of slipping. So what that means is the friction force is at its absolute maximum and it's just about to slip, so it's not moving yet. It's still in equilibrium at the moment. So here's our free body force diagram. Horizontal force P, friction force F will oppose that. We also have the weight, which is 27 times 9.8, and we've got the normal contact force, or sometimes called the reaction force, R. If we resolve forces horizontally, then we end up with R minus W equals 0, and that tells us that R is equal to the weight, which works out to be 264.6 newtons. Now for the friction, we use the friction equation, F, the friction force, must be less than or equal to mu R, and that implies that F must be less than or equal to 0.3, which was our value of mu, if you remember, up here. So 0.3 times 264.6 that we just worked out. So that tells us that F has a value which can go up to a maximum of 79.38. So as the box is on the point of slipping, F must be the maximum possible value. So now we can resolve forces in the horizontal direction, and that tells us that F max minus P equals 0, because we've only got the friction and P in the horizontal direction. So that tells us that P must equal F max, which we've just worked out is 79.38 newtons.